Hey guys, let's start off by going through the assignment. So for the nucleus, identify the atomic number, so that's the lower number. So 36 is the atomic number. Number of electrons and protons is going to be the same as the atomic number, which is 36. Mass number is the top number, which is 92. And then the number of nucleons is the same as the mass, which is 92. List the similarities and differences between the coal-fired power plant and a nuclear power plant. Well, similarities are exactly the same, except for that first step. That first step is, or the first type of energy for coal is chemical potential. Nuclear is nuclear potential energy. The rest of the steps are the same. Differences: coal fire releases SO2, CO2, particulate matter. Nuclear does not, but it does have nuclear waste that needs to be stored. Describe how a fission reaction is controlled by a can-do reactor. Well, they have those cadmium control rods to stop neutrons so it doesn't get out of control. Okay, for this one here, let's go through that. Okay, so for A, it looks like it's beta. So that's my line right there. So A is beta. And what's left over is going to be the same mass, 14 on top, but it's going to be 7 down below because 7 and -1 makes 6, so it's going to be nitrogen. B, yeah, it looks like what we're making there is an alpha particle, which makes it alpha, right? That would add it up. And then C looks like, so we have 5 on top and then 1 on the other side, so it looks like it's going to be 4, 2, yeah, which also makes it alpha. No, sorry, this one's not alpha. This one is fusion, because we're taking 2 hydrogens for C, and we're making helium, so that would be fusion. Alpha is usually when you take a big atom and it breaks up into a smaller atom, right? So C is taking 2 hydrogens, making helium, so it's fusion. For D, we're trying to find this. So what I'd have to do, and this one's a little bit trickier, is I want to make sure it adds up. So on top we have 3 times 1, so 3 neutrons, plus 107, plus 130. So I'm adding up all the stuff on this side, and there's already 1 neutron, so I'll subtract 1 neutron, which gives me 239. So that's got to be my top number, which is 239. My bottom number here, so I'll add up all these. So 0 for the neutron, so it's just going to be 44 plus 50. And then this neutron is 0 as well, so this one's got to be 94. And then if you look up what element number 94 is in your periodic table, which I'm looking at right now, it's plutonium. Okay. And it looks like we're taking a bigger atom, splitting into smaller things, so this would be fission. D is a fission reaction, taking a bigger thing and splitting into smaller things. And you see, you don't produce any beta or alpha or anything like that. For E, 90, 90, 39, 39. So the only way that we can go up is if we make a beta particle. So it's going to be beta. F looks like another alpha. And then G, to me, so it's definitely gamma. And a beta as well, right? 53 is turning into 54, so it's going to make a beta, right? And then this is gamma and a beta decay. Okay, that's how you do that one. Possible reaction for fusion power involves the fusion between helium-3 and helium-2. The products of this reaction are helium-4 and a proton. Present the described process as a balanced nuclear equation. Okay, so I'll write that over here. This. So we have helium-3. So helium-3 would look like that, and hydrogen-2. And the products are helium-4 and a proton, like this. Right, and all those symbols are given to you in your data booklet. So in your data booklet on page 8, you find the mass of this plus the mass of this, and subtract it from the mass of this plus the mass of this, and you get your change in mass, and then we use E equals mc squared. So just multiply that by the speed of light squared. So find the mass of this in your data book, this in data booklet, add it together. Remember, they're all times 10 to the negative 3, mass of these, and then you can see the answer to that is right here. Okay. Ranks the amount of energy from lowest to highest. So lowest is phase change, then combustion, then nuclear gives off the most energy. Okay, so that's the homework, that's the assignment. And now what we're going to do is we're going to do the sample diploma questions. So calculate the technology that is least able to meet Canada's increasing need to generate electricity. So the answer is C. These don't exist. Fusion reactors don't exist, so it's not very able to meet our needs. So C is the correct answer. One of the main reasons why countries use nuclear power, it's probably very expensive to build. They have a high energy output. Yes, they create lots of jobs. They don't, this is wrong, they do create thermal pollution, but the main reason would be their high energy output. They don't create it just to make jobs. 19, so the numbers of A, B, C, and D. Okay, so again, you've got to be careful of this coefficient in front. It means that there's 3 neutrons. So another way of writing this would be, just try that again. So another way of writing this would be like this, right? They say that there's 3 neutrons. So you can write it out like that if that's a little bit easier for you. So let me get out my calculator because I've got to do some adding here. So on this side, we have 239 on top and 1. So it's 240 on this side. And if we want to find out what this top number is, we have to go subtract 147, and then subtract 1 neutron, and 1 neutron, right? Because that's the other numbers that are accounted for. And we get 90. So this number is 90. And then this bottom number here, this up top, yeah, I can see a little bit better. So on this side we have 94, and then we want to find out this, so we have 38 accounted for, and then 0, 0, 0. So this bottom number must be 56. So my answer is 5690. That's each of the equations above. So if we're looking for fusion, we're looking for 2 very small things making a bigger thing. So hydrogen and helium making something bigger. Yeah, that looks like fusion to me. Fission is when we take a big atom and we split it up. Right, so this we're making an alpha particle, so this wouldn't be a good answer. But here we're taking plutonium, we're shooting a neutron at it, and split it into 2 smaller atoms. So 4 is going to be fission. Alpha decays whenever we make an alpha particle, so that's 2. And beta decays whenever we make a beta particle, so that's 3. So we're looking for steps in order to calculate nuclear change in energy. So first step, yeah, we need that balanced nuclear reaction. That's really important. And then multiply the mass of each nuclide or nucleon by the number of moles. So that's important to do first, right? Because if we had 3 neutrons, we'd have to go 3 times the mass of a neutron. Determine the mass change by subtracting the mass of reactants from mass of products. Yeah, so it looks like 3 is when we're adding up all those masses, and then 4 we calculate the change in mass, and then 2 is when we use E equals mc squared. Okay, so this one I need to find the amount of energy given off in the reaction, so let's do that. Sorry, I'm just trying to open up the data book. There we go. So I'm going to go to page, come on, there we go. So I'm going to go to page 8. There we go. This guy right here. Let's make that, oops. I'll make that smaller so I can look this stuff up. Let's get my calculator out too. Okay, so over here we have 4 of the hydrogen 1s. Okay, so we have 4 hydrogen 1s. So I'll have to look up the mass of hydrogen 1, right? See how it looks the same? So we have 4 of them. So I want to go 4 times 1.00783. And remember, they're all times 10 to the negative 3. Okay, so that's the mass of my reactants. There's 4 of them. And then we have a helium nucleus, which is an alpha particle. So that's the mass up here. And I only have 1 of them. So I'll go 1 times 4.00151 times 10 to the negative 3. And I'll add it to this. There's 2 of these. So I'll go 2 times and then look for this. This is a positron. You can see it looks the same in here. So 2 times the mass of that positron, which is 0.000549 times 10 to the negative 3. Okay, and they should just be a little bit off, which they are. So I'll take this mass and I'll subtract it from this mass. And that's my change in mass. So if I multiply that by the speed of light squared, then I have my energy, 2.58. So my answer is 2.58. 2.58 times 10 to the 12. Okay, this one, whenever we shoot a neutron, it releases 3 more, right? So when this neutron hits this one, it'll release 3. When this neutron hits this and they split, it'll release 3. And when this neutron hits that one, it'll release 3. So we will have a total of 9 neutrons. One of the difference between fission and fusion. So fission is splitting nuclei, where fusion is joining them together. Yeah. That's it. Okay, so this will be a short lesson because that took a lot of time. So this is sustainability. So describe the environmental impact of developing and using various energy sources. So we're going to talk about geothermal today. Explain the source of the tides in terms of gravitational attraction between the moon, sun, and the earth. And describe energy transformations in tidal energy and hydroelectric. Evaluate the environmental and economic implications of energy transformation technologies. So we need to know what the term sustainable means. So sustainable means it's something that is capable of being maintained at length without interruption, weakening, or loss of essential characteristics such as matter or energy. So the term sustainable works really well in nature. So in nature, trees grow from the soil. They receive energy from rain and sun, and when they die, they're decomposed into the soil so that the trees can use their matter and energy, right? So that'll happen forever and ever and ever and ever, right? Because the sun will be shining for billions of years. It'll always rain, right? They'll recycle the energy. There's decomposers. This is super sustainable, right? Where if we look at cities that we live in, why is that not sustainable? Well, garbage, right? We're losing matter with garbage. We throw out lots of garbage, it goes in dumps, and it just sits there. We don't recycle it. Well, lots of it we don't recycle. We need energy. We use our energy. Our energy source is fossil fuels, and fossil fuels are going to run out, right? Cities are not sustainable the way that they are, and we need to think at more sustainable energy sources, right? That's what we're going to focus on here is how can we use something other than fossil fuels to be more sustainable. So to be sustainable, your energy source can't run out. You can't pollute the air or water sources. It can't destroy the habitats of organisms, doesn't contribute to ionizing radiation. So the oil and gas industry doesn't provide any of these, right? The oil and gas industry will run out, it does pollute, it does destroy habitats with those tailings ponds and things like that. It doesn't really contribute to ionizing radiation that much because it doesn't do anything to the ozone layer, but 3 of 4 is bad. So we must look at alternative energy sources if we want to be sustainable, right? Also, even if we don't care about sustainability, oil and gas are going to run out eventually. So why wait until then to find alternatives? We need to start looking now. Geothermal energy is responsible for the movement of tectonic plates, volcanoes, and geysers. And it's caused by heat from radioactive decay deep in Earth's core. And this is a very important sentence because there's always questions on what causes geothermal energy. So it's radioactive decay, alpha decay, beta decay, deep in the Earth's core. So when the crust is thin enough or has fractures in it, it creates hot spots which allow heat to rise to the surface, right? So this is all this liquid magma in here, volcano, it rises up. If you get some water next to this liquid magma, it'll heat it up and it'll create geysers. But what it can also do is create this geothermal generating station. We can use this heat as a way of powering things. So this is a geothermal generator. So our source is the radioactive decay inside of the Earth. So nuclear potential energy. I don't know why it keeps doing that. Nuclear potential energy is our starting energy source, right? That's where geothermal energy comes from. So what they do is they pump down water, and it heats the water, and then it turns into kinetic energy. Anytime you have hot steam, it's kinetic energy. It turns a turbine, and then turns into electricity. Right? That's how a geothermal generator works. You'll notice that this is the exact same energy conversions as a nuclear power plant, so you can't tell the difference between the two just with the energy conversions. So advantages and disadvantages. So we'll talk about advantages first. It doesn't have any emissions, right? You still have to heat water, so it still has thermal pollution. Advantages, it'll last forever, it's sustainable. It might be expensive to put in, it doesn't work everywhere. Then that's the biggest thing, is it doesn't work everywhere. That's the biggest downfall. Oops, everywhere, not everything. Okay, so these are places that use geothermal energy, and these are tectonic plates. So places along tectonic plates is where it's thinner, and that's where it works a little bit better. So it doesn't work everywhere. Tidal energy. So the tides are caused by the pull of the oceans between the moon and the sun. The moon moves more, which impacts the tides more. Impacts on the tides. That's a bad sentence. But the moon impacts the tides more because it moves more. Depending on the shape of the ocean bay, you can get 16 meters worth of water can drain in and out of the bay every day, which is crazy. So this is what happens, and the biggest thing with tidal energy is it's a tide. It's from the moon and the sun, but we'll talk about the moon here. So the moon has a gravitational attractive force. So what it does is it makes the water bulge out here. So you'd have a high tide over here. But the thing that a lot of people wouldn't think is over here, it bulges out as well. So closest to the moon and furthest to a moon, it bulges out. And you can think of it as gravity is almost squishing it here, so it bulges out on both ends like that. So when it's high tide on this side of the Earth, it's always going to be high tide on the opposite side of the Earth. Okay, this is the Bay of Fundy. This is at high tide, this is at low tide, so you can see how much water can come in and out of there. So this is the idea of a tidal generation station, just using the tides. So tides get their energy from gravitational, oh, I spelled it wrong, potential energy. So gravitational potential energy makes the water move, so it turns it into kinetic, and then turns it into electrical. Right, so when the water goes this way, into the bay, or out of the bay, whatever one is which, it moves water across this turbine, then when it comes back in, it moves water across that turbine. So both coming in and out, it would make the water move, make the turbine move, create electricity. So advantages, it's sustainable, no emissions, same sort of thing. Disadvantages is no one uses it because it doesn't work in very many places. There's 2 places in the world that use this because it's really hard to find a bay that empties in and out enough to supply enough energy to make it worth it. So biggest disadvantages is it doesn't work almost anywhere. Okay, that is it. I'll post an assignment and that is it for the day.